All right. Hi, everyone, and welcome to the first or zero discussion of our course, Data Structures and Algorithms for UF Online. So yeah, welcome. I'm really excited for the semester. For those of you who don't know me or don't know me, my name is Andrew Kennedy. I'll be leading your discussion this semester, and I'll be one of the TAs for the course, along with Josh, or Joshua, if you prefer to call him. It's a really great guy too. And yeah, I can't wait. It'll be a fun semester. So let's get started with this discussion. Yeah. So a little about me first, I guess. So I am a fourth year student at the University of Florida. I'm studying computer science and mathematics. This is my second time TAing for this course, and before that I TA'd 3 times for round one. So overall my fifth time TAing for a computer science course. And yeah, that's my background with TAing. And a little bit professionally, like I interned at Amazon last summer for software engineering, and then this summer I plan on doing some other internships. So if you have questions on like internships or stuff like that, yeah, you can ask like related to computer science. You can always ask me about those, or really anything, like anything related to the course, anything at all. Just send me an email or on Slack. Like I'm here for you guys, whether it's course related or not. I'm always available. So yeah, that's a little about me, and that pretty much covers it. All right, so now we're going to go ahead and start it on the discussion itself. And so we have done the introduction. So yay, that's one thing done. Only 2 more to go. Although this last one's a little bit longer. That's okay. So about the course, we're gonna talk about that in a second. And then we're gonna go over a review of C++. So maybe you've taken programming 2 recently, or you know C++ pretty well, and that's awesome. If you don't, we're gonna go over it just so you guys get a refresher for this week, because it takes a little while to get back into it. I haven't looked at it in a while, and that's completely fine. So let's first talk about the course a little bit. So this course, I would say that for anything like related to computer science, if you wanted to do like any sort of internship or job, or like apply for jobs or whatever, the thing you're going to see the most is like technical interviews. And that's one goal of this course, or one thing in this course is like, we'll teach you data structure algorithms, and this is the bulk of what you're going to see in technical interviews. This is what you'll see in technical interviews. But of course, like it goes further than that, because once you understand data structure algorithms, well, it opens up other doors to understanding other things in computer science, but also it's just like really fundamental to how we program, right? How we write programs, and it helps a lot if you can kind of think about, okay, what kind of observations can I make, or things along of that nature. So that's one really great thing about this course. And yeah, it hopefully will help you think about your science in another way. It's, in my opinion, a lot of fun. So I'm looking forward to the semester, as I said. All right, and yeah, make sure that in this course you go the extra mile to fully understand lessons. If you don't, because if you just memorize it, it's not really going to help you. Because, I mean, for some questions on quizzes and exams, maybe it will, but at the end of the day, like understanding this is important, because you're going to have to write code, right? You can't do the projects if you're like, oh yeah, I know this one thing about this data structure, this topic. Like that doesn't necessarily help you. I mean, it's good to know, but even more important is understanding it. And yeah, and in order to actually solve complex problems, you'll have to understand different concepts. And as long as you keep up with the course, I think it's fine. This course is a little bit difficult, but I'm sure all of you can do well. All right, so that's about the course. Now we're going to go into our C++ review. Hopefully, all of you have maybe seen some of it before. If you don't remember everything, that's okay. That's why we're going over it. So the first thing is preprocessor directives. So these are the things where you'll see like the pound sign at the top of the C++ code. You'll see like pound include, and that's in order to, it allows you to like use different packages, and it replaces the directive with the content of the specified header file. So for example, you're able to use like IOStream because you pound included. So that's a directive. And otherwise like pound defined. So this allows you to like define a constant. So num items is a constant, which is 500 in this case. If defined, and if not defined, right? And if. And these allow you to compile certain parts, and it allows you to make sure that you aren't including things more than once or defining things more than once. And pound fragment once is another one. These are just the most common ones. I think there are others as well. it allows you to make source files only included once in single compilation, so you don't have to be as careful about making sure it's only included once. If you have like a lot of different files, this just makes sure it's only included once in action files. So these are the main ones, as you can see here. And yeah. Okay. So moving on a little bit, we'll talk about data types. So hopefully a lot of you have seen some of these data types before, not all of them. And there are characters, which are strings, right? And string isn't like basic data type, but I mean, it's pretty, or it's not permanent data type, but it's pretty like basic and important. And they're ints, unsigned ints, longs, unsigned longs, doubles, floats, bools, void, string. Yeah, and like bool is boolean. So if you just maybe you're only in Java, we call it boolean, but here C++ is just you would just write bool. Void is just like if you have a return type on a method, right, and you don't want to return anything, you use void. You have int, unsigned int, long, and these are all just like data types for numbers of different sizes or depending on what you want to use, right? So doubles and floats. And yeah, for characters and strings, right? String is basically just character array and then charts characters. So it's mostly the same as you see in Java. There are a couple differences, like bool is slightly different, and then string is included in the string library, but other than that, it's actually similar. So yeah, moving on, I guess that covers. If you have questions, of course, but anything I say here, you can go ahead and like send me a message on Slack or email, whatever. That goes for the entire course. If you ever have a question on anything, just let me know. Okay, so auto and decal type. So these are just allow you to, like on the fly, it's a lot easier than maybe having to know the type of a variable. You can like just derive it. So here, instead of saying int x, maybe I didn't know it was an int already. Right? Sometimes like it's a lot harder to write something out because it's long. Maybe it's just easier to write. So you have int and then you have auto y equals x. Then y will just be the type of int, right? And decal type also works pretty similarly. And these are almost interchangeable. There's some slight differences. Like if you have a return type of like a reference to an int, then if you try and use auto, it'll just say that the type is int. But if you use decal type, it'll actually say that the type is referenced to int. But that's kind of specific. So that's like for a specific method return. But in general, in most cases, auto and decal type work about the same, and you can usually just use auto. But that's just to make your life easier. If you don't want to ever use these, you don't ever have to. You could just use the actual type. Like instead of auto y equals x here, you could just write int y equals x. That would be perfectly fine. Okay. So poll question number 1. Oh yeah, throughout the semester, we'll just do like poll questions so that you can test your understanding so far as we go through lessons, our discussions. And so you can maybe pause and then try and answer it. And once you unpause, then we can answer. And I can't tell you to unpause because then you're gonna be paused when I tell you to unpause. So it doesn't really work. So I can't be like, oh yeah, unpause now. But like I'll say pause now, and then whenever you're done, just like unpause. So, yeah, so you can pause and try and figure out the first one and then also the second one actually, and then we'll explore both. So which data type would you use for 412 and 234.2? So you can pause now, try and figure it out. Okay, so you've probably unpaused. So good job figuring that out. If you're still stuck, then I guess you didn't get this far. Okay. So, all right, so what is 412? So 412, let's go through the answers, right? It's 412, you could use an int. Yeah, you could, right? Because 412 is an integer. You could use an unsigned int, absolutely. Could use a signed int, yep. And I guess and for double, right? You could use double, but I mean, if you wanted it to use double, it would be like 412.0. So we're just gonna say no to double here because it wouldn't be represented. Like if you were to print it out, for example, it wouldn't be represented as 412, it'd be 412.0. So we're gonna go with these answers as the data types you should use if you want to represent it in this way. Okay, and 234.2. So is this an int? You can't use an int to represent it because there's a decimal part, and ints do not have decimals, right? And you can't use an unsigned int either because of the same reasoning. For floats, you absolutely can use a float because remember, a float is just a float and double are both allow you to use decimal points, except double just has like more precision, so more decimal points. And so double will also work. So these two both work for this. So check and check. All right. Now we can go over our answers, make sure that I didn't get it wrong. And yeah, so these are our answers. Okay. All right. So now moving on to the next part. So again, this is just a review of C++. So if you know this, great. If you don't, that's okay. Okay, so ways to control actions based on logic. So one of them is if-else statements. So if-else statements, right? Hopefully kind of self-explanatory, right? Like if this, then we do that, and else if this condition is true, right? Else if x, like in this case, right? X is 0. If x is greater than 0, then we do that. Else if x is less than 0, then we do that. And then else, right? So it wasn't else if, wasn't else if, so else statement. Then we would say x is 0. So it just allows you to control where you go. There's also switch case, and this exists in languages like C++ and Java. I don't think it exists in Python, but it's still pretty common for many languages. You have a switch. So in this case, basically you're going to go to the one that it lines up with. So string str is blue. So it's going to go into the switch statement, and it's going to try and find case where blue is true. If it doesn't find it, goes to default. So in this case, it will find blue, right? And it's going to do whatever string is blue. And then it hits break, so exits the switch statement. But of course, like if this break statement weren't here, it would just keep going down to default. So that's just how switch case works. That case switch case works. And then while loops. So while loops, they keep going until the condition is met, or until the condition is no longer met, rather. So here we have while n is greater than or equal to 10, it prints out n. So it's going to keep doing this so long as n is greater than 0. And in this case, this wouldn't be good. You can think about why, but the answer to why is because this never terminates, right? It's just going to keep going because n is always greater than 0, it just keeps printing it. So n never changes. That's how while loops work. And for loops, for loops also are kind of like while loops. They just keep going until the condition is met. So every time I increments, and basically until this condition is no longer met, so until I is greater than or equal to 100, it'll just keep printing out I. Right? Okay, that's just control. Hopefully that's just a review for all of you. Okay, and pointers. So pointers, it's just a variable whose value is the memory address. So you have memory somewhere, and then sometimes the memory is very large, or maybe you have an array or whatever, and you can just point to it, right? That's how pointers work. So rather than just keep track of what's in the memory, you can keep track of where the memory is, right? So in C++, how we declare a pointer is we have the data type and then asterisk to make it known as pointer, right? And or indicate it's pointer, and then we have the name of the variable. So here we have int asterisk x, so it's an integer pointer, right? And this is just an integer. And then these two, so the address of that operator and dereference operator. The address of operator allows us to get the memory address of a variable, and the dereference operator basically just like does the opposite. If we have the memory address, it's going to get the value in that memory address. So like we see here, the number is 5. We have an integer pointer x, right? And what's it going to point to? It's going to point to where num is in memory. So somewhere in memory, we have where the value where num is, right? And this particular place, right, is now going to be pointed to by x because x is now a pointer to that location, right? But if we want to get the value there, like in that memory location, like if we just print out x, right, it's just going to tell us what this memory location is because that's what x is, right? If we want to actually have the value, we have to dereference. And dereference is like this, asterisk x, or dereference x, which gets the value inside of there. So again, just a review of C++ and pointers. So, yeah, if you have questions about that, of course, yeah. Okay, so continuing on, arrays and pointers are related, and you can always convert an array into a pointer with the same type. So here we have an array of ints, right? And then you can, as mentioned, right, you can make a pointer of the same type. So an integer pointer, right, will equal the array. And what that's just going to say is going to say, okay, this pointer, right, is just going to point to the beginning of that array because arrays are just pointers, right, in C++. So yeah. So what that's going to mean for us is these two things will print out the exact same thing. They'll both print out the third element of the array. And the reason why is because if we have our array here somewhere in memory, right, and it has 5 things, then numbers is our array, right? So print out the second thing, That's going to be this, right? But then what this is going to do, what this second print statement is going to do, is going to say, okay, first things first, we're going to do num pointer plus 2. And what that's going to say is, okay, what is num pointer? Well, it's a pointer to the beginning of the array, right? Or to where the array starts. So it's a pointer here. So by adding 2, we're doing pointer arithmetic. So we're adding 2 to the pointers with what the pointer is in memory, right? Since these are ints, it'll advance by 4 bytes, right? So it'll go 4 spots, or it'll move 4 bytes twice. So it'll go 2 positions in the array for down. And it's going to go from like this place down to this place, because we're going to advance it 2 spots. And then we're going to dereference. So when we dereference, it just gets the value in there. So right now, right, if we don't do this dereference, it's going to give us the memory location that's here. But when we dereference, it just gives us the value in there. So these two print out the same thing. Okay. So again, pointer arithmetic, you can do in C++, and you can add or subtract to a pointer, which allows you to go forward or backwards, for example, in an array. And yeah, because ints are of 4 bytes, then if your byte is just 1,000, you advance it 1, it's going to go to 1,004. As we see in this example, something like that, right? Okay. So arrays. So arrays, you declare in, sorry, you have the data type, and then you just have the name. So for example, int grid, in this case, int grid, right? And then you have the size inside of the brackets. And you initialize it. You can initialize it with, if you give it like size, you can just set it equal to the values if you want at the same time as you initialize it. And just like in Java, and just like referring to as plus as before, right? Nothing's changed in C++, nothing major, right? No, nothing, yeah, nothing major. Like, oh no, you can't use arrays anymore like that. Yeah, you can just use the brackets to access elements. And for a multi-dimensional array, you have to just use extra brackets. So hopefully that's not anything new either. And yeah, this int grid line will create an array of 4 elements, each of which has 5 elements, which are integers. So that would create like a grid, right? 4 rows and 5 columns. There's also the array in standard library, which is just the array, but with extra wrapper. It wraps extra abilities, so things like size. But generally, if you're using array, you might as well just use vector because it allows you to actually resize the array dynamically, which is nice. So yeah, so there are ints and then arrays and vectors and all that good stuff. Right? Okay, and arrays as arguments. So yeah, you can pass an array into a function. And when you do that, you're passing the address to the start of the data. And yeah, and you can do the same thing with multidimensional arrays, because it's still an array. But the interesting thing is when you do that with multidimensional arrays, you actually have to pass in every dimension except for the first, because otherwise, like your program won't know how much memory is being passed or like what is being allocated. So like in this case, what we notice is we have a 2D array, right? Array 1, and it has 2 dimensions. The first one, it's just, well, it's 2 by 3, right? So 2 rows and 3 columns. We need to actually indicate that there's a 3 here. And the reason why we need to do that is because when we actually pass it, it's gonna, like these are, the first dimension is really just a pointer to the second dimension, or if it was more than one, same thing, each dimension. So it needs to know how much like data is there that is allocated that needs to actually go and get, right? And otherwise it wouldn't be able to actually get the values. So in C++, you actually need to give those dimensions of everything after the first one. But otherwise it's exactly the same. So when you're passing an array, right, you pass in just like in this case int array, and the second one int array 3. Okay. Right. And so yeah, that covers arrays and arguments. And so for dynamic memory, so sometimes, yeah, you don't know the size of something. And in that case, like ahead of time, like if there's a user input, you have to use dynamic allocated memory. So memory that's going to go in the heap, right? Rather than memory that goes in the stack. And so you have to use the new keyword, right? And then of course, the new keyword goes delete keyword. So for example, if you're given an array size, it's based on user input, you can't just do this, you can't do int array user input. That's a no-no, because you can't do that because you have to have, in order to dynamically allocate memory, you have to give an exact size, or you have to, sorry, if you want an exact size that isn't known at compile time and you want to have it at runtime, then you're going to have to dynamically allocate, right? And the way we do that is we use the new keyword and put in. So to some examples here, this creates a new integer, this creates a new integer pointer, so like a new integer array of user input, and this is just 3. And then once you're done, like we mentioned, you have to use delete. So if you want to delete a regular pointer, right, to an int, for example, you use delete. And if you want to delete an array, then you have to delete the array. So you do delete, right? Foo array. If you don't do that, you'll have a memory leak, right? I'll talk about why that's bad. So yeah, in fact, I'll have you guys answer this if you want. So what exactly are memory leaks? Why do we care about them? And what's the difference between these two lines of code? And then one final question for you guys is, how do you remove node B without causing memory leak in this linked list, assuming all of these nodes were dynamically allocated? How do we remove B without causing memory leak? So try and answer, and then we'll go over it. So yeah, pause, and then unpause when you're done. Okay, so let's go over this. So what exactly are memory leaks? In fact, I'll just put it next slide. So yeah, leaks are when you have like pointers or unreferenced pointers to dynamically allocated memory. So basically, you allocated memory at some point, and now you no longer have access to it. And that's bad, right? So like, let's say, yeah, I was using some pointer and I never deleted, or I dynamically allocated memory, I never deleted it. That's bad because it's wasted memory. So it'll be cleaned up after your program executes. But if there's too much of it, then, well, first of all, it can slow down your program. And the second thing is memory can run out. And if memory runs out, then your program won't be able to not finish, right? And even though for simple things like this may not seem like a problem, for larger scale projects, this can be bad because, for example, if you have a program that's continuously running, or there's a lot of different parts to it, maybe yours is a small component, then even a little bit of memory that yours uses and doesn't delete can be bad because in a larger system, right? So memory leaks in general are a bad thing. And the difference between these two is that in the first one, right, you're creating dynamic memory in both of them, but the first one is just an integer and the second one is an array, right? And how we clean them up would be different because the first one you can just delete the pointer, or you can delete E, and the second one you'd have to delete E as an array, right? So it would be similar to what we had here. Go back where we deleted as an array and we deleted as a pointer. So in order to delete the first one, you just delete, the second one you delete, and then array. And how do we remove B without causing memory leak? Well, first and foremost, right, we have to remove B. So how do we do that? Well, in order to remove it from there, we first have to create a pointer to B, right? So I don't know, make pointer, something points to B. And then we also, if we want to get rid of B, then we have to skip over it, right? So we have some pointer at A, which is just probably the start of our linked list. And that pointer then is going to have its next point to C. So now, if we actually look at our linked list, it's going to be like this, right? But there's still a problem, which is that B still exists somewhere in memory. And so in order to actually prevent the memory leak, we then have to delete B. So since we have a pointer to it, we can just delete pointer. Now notice we didn't do this first step where we actually create a pointer to point to B, right? If we didn't create this PTR, that would be a problem because then we never would be able to delete B because there would be nothing that can access B anymore because this, like, let's just say ACD, there'd be nowhere to get to B. We still need to delete it because it's memory leak, so that would be a memory leak. So the way we fix that is just create some pointer to it first and then delete that. So yeah, pointers to B and C, A's next pointer to C, and then delete. Okay. So functions, C++, similar to Java, and everything is passed by value unless you specify otherwise, which is actually kind of nice because it gives you some control. And so as an example, right, you have int a is 4 in both of these cases. So both these are exactly the same so far in main. But when we call square a, for the first one, notice it's just int a. So because we did that, this is going to just pass by value. So when we just pass by value, it's just going to basically copy whatever value is here. So it's going to copy the 4. It's going to pass in a 4. This is going to be 4. It's going to be 4 times 4 equals, or a equals 4 times 4, right? So a is now 16. But notice that this a, right, is different from this a. And it's different because we passed by value. So we just copied the value over there. We didn't actually copy the reference to it. So a is 16, that's a different a. So we print it out, it just prints 4. However, in the other one, because we have this ampersand a, that's passing by a reference. So when we actually call square a here, this a and this a are the same a. So when we do a times equals a, that's going to be 4 times 4, but it's actually going to change the value of this a because they're the same a. Like they're in the same place in memory, right? Both a's are point to the same place. Whereas with this one on the left, right, they're two different a's, like two different variables in memory. But the right one is the same place because it's just a reference. So we're going to reassign it 16, or we're going to change the value to 16 and then print out 16. Okay. So structs and classes, what's different from struct and class? Only difference is that, yeah, structs, everything's public by default, and in classes, everything is private by default. So yeah, if you, for example, wrote private and public to indicate which is which, everywhere, then they do the same. But in this case, right, struct, int length, int width, these are public. And in class, my shape, int length, int width, these are private because we didn't specify ones in a class. Okay, templates. So templates are kind of nice, as you guys may remember from Programming 2 project if you did it. And yeah, they allow you to create generic data type functions and classes. And yeah, rather than having to specify a type for every single thing you want to, or for example, if you had a linked list class, right, having to specify what the type would be for every kind of type wouldn't be possible. So templates allow you to create it for any type. And yeah, we can use template T, and it works like this. It's my type here, A, and my type B, and it's just going to return the larger of the two. If A is larger than B, it returns A, otherwise it returns B. So yeah, that's kind of how templates work. And a little more on templates. For class templates, you only have to prepend it at the beginning. So you have to only put it at the beginning of the, before the class declaration, not all of its functions. And the syntax for the function requires template as well. So here, for example, in here we have a template heading for this class linked list. Then we actually want to use it here for a linked list. For a linked list, we want to set the head linked list. We actually have to put it there. But yeah, if you want to know more about templates, you can look here for more information. But yeah, hope that's kind of just a review of templates. And moving on, another poll question. So which of these are true about templates? So you can try and pause and figure it out. And I can read over the answer if you want. So we can write one template function that can be used for all data types, including user-defined types. We can write one template class or struct that can be used for all data types, including user-defined types. And the last option is template is negative or polymorphism. So which of this do you think it is? Pause and figure it out. We'll talk. Okay, so you've unpaused by now, or you skipped over and you got here. So welcome. And so the answer in this case is actually just 1 and 2. And the reason why is that we can write one template function that can be used for all data types, including user-defined types like sort and max. We just saw that a moment ago, another slide, because you can just sort, because you can compare one object to another, and it doesn't matter what the object is, as long as you can compare them. And we can write one template class or struct that can be used. And I think for programming 2, I think one of the projects is actually for a linked list in which you use templates. So hopefully that's a review. If not, then if you didn't do that there, then yeah, you can absolutely do this. One template class or struct for any user defined or anything. And we also saw that on the last slide. And the last option is not true. actually, it's an example of compile time polymorphism. So compile time, my handwriting is really bad. It's just, that's compile. Yeah, it's not an example of runtime polymorphism because at compile time, it has to figure out what the type is. It's not doing it at runtime. Isn't figuring out at runtime what the type is. Okay, because like when you are actually using it, right, you have to still, like if you're using, for example, a linked list class you created yourself, that the type that you're actually using will be defined at compile time, rather than it trying to figure it out. Although with templates, it's going to figure it out on its own without you having to define every single type. Okay, but basically, all that I'm trying to say is compile time, or it's compile time polymorphism for templates. Okay. So 1 and 2. Okay, so const keyword. So what is it? So it's a way of indicating that a variable is not allowed to change, right? So kind of like final in Java, and const data type name is value, and data constant name. And when dealing with pointers, then these basically mean the same thing. It just means you can't change the value of your data type, or the value, sorry, of your data. So in this case, whatever this is named, like if I said const int x is 10, I can't change the value of x from 10. However, when you deal with pointers, it's a little bit different because that const can mean multiple things. So if you have a pointer to it, so like int asterisk x, like this is a pointer to it, right? So that's just a pointer, an integer pointer. But if you have a const pointer to a mutable int, so what that means is basically that if you were to write it like this, int asterisk const x, what this is your pointer is constant. So what it points to can't change. So like there is somewhere in memory, right? If you write this int asterisk const x, that means that there's some memory location, right? For x. And that memory location can't change. So x will always point here. Always, always, always. However, let's say the value in there is 4. You can still change the value of 4 like 10 or whatever you want. And that's perfectly fine. But you can't change where x points. So now x can't randomly now point over here instead. Like that it cannot do. Okay. And the next one is constant int asterisk x. So this is a pointer to a constant. And this one maybe is a little more clear. And this is maybe makes a little more sense, I think. At least makes more sense to me, or more clear to me. And you can write it either way like this. Is if now suddenly I have still x, right? And let's say it points here, right? And it points to somewhere in memory, this is 10. Now I can't change this value 10, right? This value 10 can't change. However, instead, what I can do is I can actually reassign x to point somewhere else. And maybe in this other place, there's a 4. That's okay. So x won't point here anymore. I can reassign it to point here. But if we go back through this, but I can't randomly say, oh, let's change this value 10 to 4. That's, no, that you can't. Okay, so that's a pointer to a constant. And the last one is a constant pointer to a constant. And in this case, this one is just a combination of the two. You can't change where x points, and you also can't change the value in that position memory. So there's somewhere in memory, x points there, and you're like, nope, x can't point anywhere else. And also what you point to can't change. The value there, no changing. So nothing changes. Hopefully that, I don't know, maybe a little bit confusing. Hopefully it's kind of clear. Again, if you have a question though, like, just reach out. Okay, and const objects and functions. Let me move my head because I think it's in the way. Okay, so const can be used at the end of a class's function declaration. So like this, int get length const on the right here. And what this means is that the state of the object in this function cannot change. So like here, nothing about the rectangle will be changed. Like there's nothing, like often getter methods in particular are often const because you don't want the value to change or any values to change, right? If it's just a getter method. And if it does change for any reason, then there will be some sort of error or compiler. And here we have const. So that's what const means for a method. And then when you actually create an object, like here, rectangle, R2, there you can also put const. And what that's going to say is, okay, once this object is created, once it's called the constructor of the object, right, and the values there can't change. And yeah, what this means is that now R2, like this object, you can't change the values of it. It'll always remain the same. And if you actually try to call a non-const function, it'll give an error. And the reason why it'll give an error if you try to call a non-const function is because non-const functions don't guarantee that it won't change the variable, right? It won't change anything about R2. So to just avoid that, you can't call non-const function objects. So still hopefully just a review. But what do we do if, say, we want to be able to actually set the variables? Like we can't, for a const object, right, or const, yeah, for const memory variables, right? For example, here, length and width are both const, right? But they're member variables, so it has to be set in the constructor somehow. But the way we do that is we use an initializer list, which just looks like this. And it just sets the values of L and W, length and width, to whatever these are. And that's all it does. So it just says, okay, when you first create the object, you can set these values, but in the future, they can never be set again. So it allows for setting them when you first create an object, but they won't change. That's all. So that covers const memory variables. And then I think that covers our whole review of C++. So hopefully a lot of that made sense and you're getting back into C++, you haven't looked at it for a while. And yeah, that covers that. So yeah, again, any questions, just chat. I know it's a lot, but first day, our first discussion. But one thing I did want to be very clear about is in this class, please do not cheat. Like, please, please, please don't cheat. And I'm really serious about this because it always happens. I always give this feeling, people always cheat. And I hope this semester is different. I hope no one does cheat because if you do, it can ruin your academic and professional career. And you can't really cheat in the workforce in the same way you can cheat in school. And and if you do cheat in school, you will get caught. So it's bad because you'll get in trouble. I'll feel bad. And yeah, it can ruin your academic and professional career, which is bad also. And if, for example, you get an internship or you get a job and they find out you cheated, you ran into it, you might ruin your connection with them. And that really does happen, by the way. And what does cheating entail? Well, use your best judgment. Hopefully your best judgment means that like you know that you might be able to figure out better, but if you aren't sure, that's fine. You can't copy and paste other people's code unless we say otherwise for any reason. But yeah, in general, no, don't copy other people's code. You can't give away, show, or sell your own code. Hopefully that's self-explanatory. You can't copy online code from online without citing it. Or you can't copy code from online, but you can't use any like code from online without citing it. And you can't copy code or assignments or whatever from previous semesters unless, for example, it's something where we tell you you can use like something that you wrote in a previous semester. But you'd have to ask us first just to make sure. And stealing code from other people's GitHubs is absolutely a no-no. That does happen. I have a friend who actually did it in mental, so yeah, don't do that. Or they were a friend, I don't know. I'm just kidding. But no, but seriously, like don't make like cheating is bad, don't do it. Okay, so additional review resources on a lighter note, just yeah, if you want to review more, these sources, and that's about it. Yeah, thanks for listening, and thanks for watching this session. I'll see you again next week, or I'll see you in office hours and whatever. Nice to meet you all. Goodbye, and yeah, have a nice week.